Hi, welcome back to week 3, lecture 2, part 1. In this lecture we're going to cover what's called truth functional truth. And we're also going to cover truth functional falsity. So let's do this. Okay, so remember before we talked about logically true. And we also talked about logical falsity, right? So when something is logically false. So these now are going to be our truth functional versions of what we intuitively before called logically true and logically false. So, oh, there we go. Oh, yes, and we're also going to talk about truth functional indeterminacy as well. Indeterminacy. And this is supposed to be an analysis or be the sort of semantic version of what we called when the sentence is logically indeterminate. Okay, so let's go over an example of a sentence that we thought, that we called before logically true. And remember, this was a sentence that said something like A or not A, right? Sally went to the party, or it's not the case that Sally went to the party. So in SL, the way we write this more formally is to use our disjunction symbol here, and then tilde for not, and A. And strictly speaking, we should maybe even put parentheses around here, but by convention we can drop these because there's no ambiguity possible here. Okay, so we have A or not A. What does the truth table look like for this? Well, notice that we only have one sentence here, which means that our truth table will only need 2 rows, right? One for the assignment of true to A, and one for the other truth assignment where we make A false. So we just need the scenario where A is true and A is false. And I'm just going to use lowercase t and f to designate the truth values rather than the capital letters, just to make it clear that this here, A, is a sentence in SL, and these are the truth values. Okay, so whenever we want to determine the truth values for a sentence under different truth assignments, we first write the atomic sentences to the left, and then we have a bar that ideally should go all the way down, but since I'm just using a very simple text editor, I can't do that as neatly, so I'm just going to leave that here and use lots of spacing to make it clear where the different columns are. And then we write the sentence. So we have A or not A. Okay, so remember to fill out a truth table, the first thing we do is copy the truth assignments under each of the letters, each of the sentence letters. So under this row, we assume that A is going to be true, and then we're going to copy that under each of these columns. So here A will be false. Okay, and the next thing we look at is this connective, right? We're always going to the innermost connective to evaluate that. And negation always flips a truth value. So when A is true here, then not A is going to be false. And when A is false, negation turns out to be true. And now we have the disjunction as the last connective we need to look at. And disjunction looks at this component right here, so the negation, and it's the left side component, which is just A in this case. And remember, disjunction says that as long as one of the components is true, then the whole disjunction is true. So here, A is true, but not A is false. But since at least one of them is true, we assign true to the disjunction under this truth assignment. And in our second scenario here, we have A is false, but not A is true. So given the rules for disjunction, we assign truth for disjunction. So notice that under either truth assignment, right, whether or not A is true or whether or not A is false, the whole disjunction comes out true. And now we have a nice sort of semantic, rigorous way in SL to capture the sort of notion of logical truth that we talked about before, where here we're going to call this truth functional truth, because we're doing this in terms of the truth tables. Okay, so that's an example of a sentence that comes out to be truth functionally true. So let's maybe say what exactly we mean by, let's give a definition of truth functional truth. And do the definition. So if you look, this is on page 84 of the textbook, and it goes like this. So a sentence P. So notice again that I'm picking a meta variable here, right? P is a meta variable, and it can stand for any sentence, either an atomic sentence or a complex sentence. It doesn't matter. So any sentence P of SL is truth functionally true if and only if P, so that's, say, whatever sentence you plug into this first P, you're going to use the second sentence, the same sentence in this case, is true on every truth value assignment. So all this means is, here we had a sentence and there are only two possible truth value assignments. And under both of them, this sentence, A or not A, is true. So again, in our example, our sentence is A or not A. That's what we're plugging into P. So we say a sentence, namely this one, is truth functionally true if and only if this sentence is true on every truth value assignment. And that is in fact the case, just as we showed here. Okay, and similarly we can do the same thing for truth functional falsity, which we'll cover quickly here as well. So I'm just going to copy this, and I'm going to change this to an and we'll actually just restart this part. Okay, so remember A and not A. So Jane went to the party, and it's not the case that Jane went to the party. Intuitively, we said that's logically false. Why? Well, because under any possible scenario which where the world is, that sentence always ends up being false. So we can give this a more rigorous characterization using the semantics of SL. So as before, we put we copied the truth values of this assignment here under the atomic sentence letters for our sentence. So under this assignment, A is true, and under this assignment, all the occurrences of A are false. And as before, we do negation, so that always flips to truth value. So here, since A is true, negation says, okay, we make this false. And under this truth assignment here, A is false, negation takes the opposite of that, so it becomes true. And now we evaluate the conjunction, right? This is our next innermost truth functional connective that we need to evaluate. And here, remember, conjunction says that both components have to be true if the whole conjunction is going to be true. But in this case, we have not A. Not A is false, and only A is true. So we have to assign false here under this truth value assignment. And under this truth value assignment, we look at the left side component, which is false, and conjunction says, look, both components need to be true if the whole conjunction is going to be true. But one of these is false, so I have to give you false here. And now you notice that under either scenario, under either truth functional assignment, truth value assignment, sorry, the sentence, namely this conjunction, turns out to be false. And so now we get a similar definition for truth functional, when a sentence is truth functionally false. So let me just do this. So we can give a definition of truth functional falsity. So a sentence of SL is truth functionally false if and only if P is false on every truth value assignment. Okay, so that covers our more rigorous semantic version of logical truth and logical falsity by using truth tables to give our definitions of truth functional truth and truth functional falsity.